All right, let's move on to 16.4. So this is page 10. On your notes, at the beginning, we have these 5 letters, CP, CTC. So that's a rule that means when you have 2 triangles together, or 2 triangles congruent, then their parts are congruent, sides and angles. So whatever parts match up, we call those corresponding. Okay, so the corresponding sides are congruent to corresponding sides, corresponding angles congruent to corresponding angles. Okay, so it's important that the triangle be written correctly as far as the lettering when you name the triangle. That way the parts match up. All right, so let's see. So the proof here, CPCTC, stands for corresponding parts of congruent, so corresponding parts of congruent, so that's CPC, corresponding parts of congruent triangles are congruent. So that is just what we just barely said, where the matching angles are congruent and the matching sides are congruent. Okay, so the corresponding parts, corresponding triangle or congruent triangles are congruent. So this is used when we're asked to prove that triangles not triangles, that's the next one. Used when to prove like angles or sides. Let's back that up. So they're corresponding parts, so we're proving parts are congruent. All right, so we're going to prove like angles or sides are congruent. And that's when you use CPCTC. So first you have triangles congruent. So first your triangles are congruent, and then you can say the parts are congruent, angles or sides. All right, so in a proof, we would first, if CPCTC is coming into play, first we would show 2 triangles are congruent. Then an angle or a side would be congruent to each other because of corresponding parts. All right, let's see what we have here. Let's write in the given. I have AB congruent to AD, and I guess I can use the second line. BC congruent to DC. Those are both given. Okay, so let's mark it on the figure. AB, AD, and then the second one is BC and DC. Okay. Now let's see, what do I know? Looking at the figure, I want to prove that angle BCA, I want to prove this angle right here is congruent to DCA. Okay. I don't have any parallel lines or anything, so I'm going to have to show those 2 triangles are congruent first. Then I can say those 2 angles are the same by corresponding parts. So let's see, what do I know? I have this side, I have 2 sides. If I had a third side, I could say the triangles are congruent by side, side, side. And this AC right here is in both triangles, so let's use that. We'll say AC is congruent to, let's just say AC. I don't think it has to be CA. So AC congruent to AC, that is what, reflexive? Okay, so now the 2 triangles are congruent. So we would say triangle, and let's name it ABC. Would be congruent to triangle, and we'll name it in the same direction. If we go ABC, we have to go ADC. And the reason is side, side, side. So those 2 triangles are congruent by side, side, side. Now, our proof is done. Angle BCA is congruent to angle DCA here because of corresponding parts. So we proved the triangle is congruent first, and then corresponding parts. All right, let's look at number 2. Let's see, right in the given. PS is parallel to QR, and we have angle QPS is congruent to angle SRQ. So those are both given. Let's go mark it. PS parallel with QR, let's mark those. And then angle QPS, so this angle, and SRQ would be that one. Okay, so what do we have? Well, with parallel lines, we can find congruent angles. So let's see, I want to prove that side PQ is congruent to side RS. So I'm going to probably have to prove this triangle, QPS and SRQ, probably prove those two triangles congruent first, and then their parts would be congruent. So let's work on proving the triangles congruent. I have an angle, I have a side congruent to itself, maybe I'll just write that in. So let's go QS congruent to SQ, I think is how it would end up being named. That's reflexive. So let's mark that. I need another angle. Let's use the parallel lines. So in our givens, we use the parallel lines to find angles. So let's use the parallel lines and find an angle. Let's find that angle and that angle. So that angle is PSQ, alternate interior angles. PSQ, and so RQS. Those are alternate interior angles. All right, so now I have the two triangles congruent because I have two angles and a side. So that would be angle, angle, side. It's not angle, side, angle because the side is not between these two angles. So here's the two angles. The side is not between them, so it's angle, angle, side. So let's just write down the triangles. Triangle, how do you want to name it? PQS, congruent to triangle. So if I go PQS, and I have to go RSQ. So if those two triangles are congruent, we had angle, angle, side. Now the parts are congruent. So therefore, PQ, this side, and this side, SR, or RS, be congruent because of the corresponding parts. All right, that's how corresponding parts proofs work. Let's see what we got here. I'm going to leave you those 3 to do for yourself. Then the next, okay, the next says the next 8 proofs are optional. And I'm going to work a few of them right now, and I will give you extra credit for those that you complete correctly, other than the ones I do for you right now. So if you want some extra credit, follow along, do the ones that I do, and then complete as many as you want after that for extra credit. Okay. Now, let's see. Here we go. These are a little easier because they're, they have the statements in there. But let's fill out the givens. WX bisects angle ZXY, given. ZX congruent to YX, given. And let's see. So let's go back and look at what we have. WX bisects angle ZXY. So I know that this angle and that angle would be congruent wherever that shows up. That might be the next statement. ZX is congruent to YX. So these two because of the angle bisector. So I think that's what number 2 would be, is the angle YXW is congruent to angle, if I go YXW, then I go ZXW. Okay, those two angles are the same because of the bisector. We have this given that I've marked. And now, what's the reflexive property? So it would have to be something congruent to itself. Well, what am I trying to prove? Triangle ZXV, so this one and this one. Okay, so XV would have to be congruent to itself. That would be the only reflexive property item in those two triangles right here. So XV congruent to XV. And the reason it's not VX is because in the statement, XV, it's the same. Okay, that's congruent to itself. So what's my rule? Side, two sides and an angle in between. So side, angle, side would be the reason those two triangles are congruent. So then we're done. Let's see. I'll skip that one. You can do number 2 for extra credit if you'd like. I'll do number 3. AC congruent to DE. So let's mark that. AC congruent to DE. That is given. B is the midpoint of AD and CE. That's given. So if you have a midpoint, that means you have congruent pieces. So if B is the midpoint of AD, that means AB is congruent to BD, definition of midpoint. So we'll write that in for the next one here. AB congruent to DB, and it's B is the midpoint also of CE. So that means this one will be congruent to this one because of the midpoint. So let's go to because of the midpoint, we have CB congruent to EB. All right, now the two triangles are congruent, 3 sides and 3 sides. So ABC congruent to DBE because of side, side, side. Okay, I'm gonna let you do 4 if you wanna do extra credit. So I'll do 5 and 7, and so I'll leave you 1 on each page that you could do if you'd like. Let's see, what is given? DF, it's not written in any others, is it? 2 givens are right here, so all right. DF is parallel to HG, and I'm going to mark it. DF parallel with HG. F is the midpoint of EG. Oh, that's the... Oh, wait a second. Oh, there's another given, sorry. This is given. I was only reading the first line and seeing 3 givens. All right. So now the third one is this DF and HG. Congruent. Congruent to HG. They're parallel, but they're also congruent, it looks like. Okay. F is the midpoint of EG, so that means we're going to have congruent pieces. Let's find out where that goes. EF and FG because of the midpoint. Oh, right down here, number 5. Definition of midpoint. Okay. So number 4, where are the corresponding angles? That's from this pair of parallel lines, our corresponding angles. We'd probably want them to be in the 2 triangles we're trying to prove congruent, DEF and HFG. So maybe this angle and this angle would be the corresponding parallel lines cut by the transversal. Corresponding, okay. So we'll say angle DFE is congruent to angle HGF. Now we have side, angle, side. All right, let's see. Last one I'll do. And then you have some opportunities. Let's see, what do we got? Given? Let's mark it down. SU and RT bisect each other. Well, that means then their parts are equal. So if they bisect each other, those 2 would be congruent, and these 2 pieces would be congruent. Now, we'll see where they come into play. Probably statement number 2 here, it looks like. SV and UV RV and TV. Yes, okay, that is because of the bisector. What's the other given? ST is congruent to UR. Let's mark that, ST and UR. Oh, side, side, side I can see, but we're not trying to prove that. We're trying to prove two angles. So first we need to prove the, oh yes, here we go. Prove the triangle's congruent by side, 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 then the corresponding parts for the angles. All right, so what are the triangles? Let's say SVT. Triangle SVT would be congruent to triangle. So if we went SVT, I'd have to go UVR. So the important one is the first one that you write, so you have to match the second one to the way you wrote the first one. And then number 5, the two angles are congruent because of the corresponding parts. All right, so now that's the end of the packet. So you have some opportunity for extra credit, one on each page of those proofs. And there you go.